Good evening, class. We are looking at practice test number 1, module 1, chapter 2, which is about equations and inequalities. Here's the second portion, part 2. More examples. So in this question, says first solve the formula for W. Which formula? P equals 2L plus 2W. That is the perimeter of a rectangle. Then use your result to find the width W of a rectangle whose length is 15 and whose perimeter is 58. So we have some information from basic algebra or geometry. Here's a rectangular shape. Here's the width. Here's the length. And here's the formula. We want to solve for W. So we are going to move the 2L and subtract it from P. Then we divide both sides by 2. And if we divide both sides by 2, we get this one. Now, before we move on, I want to make sure you understand you can't cross these two. But you need to understand, if you want to do that, you could rewrite it, and you don't have to. You could rewrite this as P over 2 minus 2L over 2, which becomes P over 2 minus L. That you can do. However, you can't just drop the 2. In the second part, it says we know P is 58. We know the length is 15. So let's replace. This is 30. 58 minus 30. 28 divided by 2. The width becomes 14. Pretty straightforward. Perform the indicated operation, and to do that, we see I, so I'm reminding you of complex numbers that are in the form of A plus BI. A is the real part, B is the imaginary part, and I is defined as square root of -1. So if you happen to have square root of -n, it's the same as I times square root of +n. If you multiply complex conjugates, A plus BI and A minus BI, remember we get A squared. Let me just show you what happens here. You get A squared minus B squared, I squared, and I squared is -1. So that's why we get A squared plus B squared. Now, when you want to do part A, you just distribute. So -1 times -2, that's +2. -1 times 3i, -3i, 2i times -2 minus 4i, 2i and 3i, the product is 6i squared. As I mentioned, I squared is -1. So let me remind you of the powers of I. I, by definition, is square root of -1. So if you square that, becomes -1. If you cube that, that means multiply this one by I, and multiply this one by I, becomes -I. And if you raise it to the power of 4, raise this one to the power of 2, becomes the power of 4. This one to the power of 2 becomes +1. So I to the power of 4 is 1. So we're going to replace this with 6i squared becomes -6. We can add these two numbers because those are real parts. We get -4, and these two parts -7i. Division. The way we divide complex numbers in order to get to their standard form of a plus bi, we are going to multiply by the complex conjugate of the denominator, and therefore we multiply and divide because this fraction equals 1. It makes sense. Now, let's see how we do the multiplication. The top, we just do the foiling. 3 times 2 is 6, 3 times I is 3i, 4i times 2 is 8i, and this 2 is 4i squared. This 2, instead of foiling, again, I'm going to remind you, a squared, which means 2 squared minus b squared, plus b squared. Remember, -1 plus 1. The b is -1 or plus 1. Makes no difference when you square it, becomes +1. So this is 2 squared plus 1 squared. That's the denominator. So this changes to -4. Again, we can add up the real parts. We get 6 and -4, 2. The imaginary parts, 11i. The denominator, 4 plus 1 is 5. Now, if you left it like that, it's okay. However, why am I rewriting it in this format? Because I want you to see, if somebody says, okay, what is the value of A? It's not 2, it's 2 over 5. What about B? It's not 11, it's 11 over 5, including the sign, okay? All right, how about this one? 9 comes out as 3 squared of -1. You don't leave it there, you change it to I. Take a look at this. So this is 3i plus 3 times. This is 4i. 12i and 3i, they add up to 15i. We have I to the power of -6. We can write it 1 over I to the power of 6. And there are a number of ways to handle this. One easy way, notice this is I to the power of 4 times I squared. Why I to the power of 4? Because we know I to the power of 4 is 1. So 1 over I squared, that means 1 over -1 or -1. Okay. So what is the process? I'm going to show you with this example. If I want to simplify this, what do I do? Here's my method. The fastest and easiest way is to divide this number by 4. It doesn't matter what the answer is. I'm interested in the remainder. Because if I to the power of 4 is 1, then powers of 4 also will be 1 because 1 to any power is 1, right? Now, as you recall, is this number divisible by 4? You look at 25. 25 is not. The remainder is 1. So this is the same as I to the power of 1 or I. Just to make sure you got that. What about this one? I'm going to divide 43 by 4. Again, I just need the remainder. Clearly, everybody knows it's 3. So the answer is I cubed, which we showed it's -I, everybody. Okay. All right. Let's remind everybody about square root property or principle. If x squared is a, where a is a real number, x is plus minus square root of a. For example, if you happen to have 49, x is plus minus 7. How do we solve quadratic formulas, we can do it by completing this square. By the way, you don't have to use the completing the square unless they ask you, but the reason we discussed that because we need that later on when we look at conic sections. So if it's ax squared plus bx plus c equal to 0, how do we handle it? Number one, a perfect square trinomial is a trinomial that can be expressed as the square of a binomial. An example is x squared minus 10x plus 25, x minus 5 quantity squared with that. And note that if you divide the b, which is negative 10 by 2, becomes negative 5, and square it, you get this one. So note that in every perfect square trinomial, the constant term is the square of 1/2 of the coefficient of the x term, or b over 2a squared. Therefore, in this case, you divide b over 2 squared to both sides. Okay, this becomes x plus b over 2 quantity squared, and this becomes this one, and you solve it. Now, what I want to add is that always carry out the sign of b over 2, because b over 2 is negative. That's what you get here. If it's positive, that's what you get over there. Now, what if it's ax squared? You do the same thing. You take the c to the other side and you divide everything by a. Okay, so that's the methodology. You remember the quadratic formula. So if you can do this by factoring, you do it by factoring. If you can't, you do it by the quadratic formula. You don't have to do it by the completing the square unless you're asked. So ax squared plus bx plus c equal to 0. X is minus b plus minus the squared of b squared minus 4ac over 2. Now this is the discriminant, and it gives you a lot of information. Like what? Recall, when it's positive, it gives you two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. B squared minus 4 is equal to 0. There is only one real solution. If it's negative, there is no real solution. Instead, we have two complex solutions, a plus minus bi. And if b squared minus 4ac is a perfect square, then this can be actually factored. We can factor it. So that's one way to know if a quadratic expression can be factored. So by completing this square, of course, you don't have to do it by this method, but specifically it's as we, number one, move the constant, and number two, we make sure a is 1, and now b is 6, divided by 2 is 3, and squared becomes 9. Let's add this to both sides. And what happens to the left, remember, it's b over 2, which is 3. So x plus b over 2, x plus 3 squared, and the right side is 2. Now, again, including the sign, whatever this is comes here. Okay, everybody? So number 3 shows up here. All right. Now, the rest is simple. Take the square root of both sides. And the right side is plus minus square root of 2. You use the plus minus for one side and move the 3. And this is the exact answer. This is the precise answer. If they ask you for a decimal representation, they will ask you how many decimals. Then this is about 1.41. You add to this and you subtract from it. But you know, however many decimals they ask you. In this case, it's a function of z instead of x. It doesn't matter. First and foremost, we are going to move the -4, make it a +4 to the other side. Secondly, this number is 2. We are going to divide everything by 2. And one way to write it, you can even write it like this. That means you're dividing everything by 2. So what happens? This becomes z squared. This becomes -7/2 z, and this becomes 4/2 or 2. We need to find b. which is negative 7 halves. We are going to divide it by 2. Negative 7 halves divided by 2 is negative 7 fourths. And if you square it, becomes 49 over 16. I'm assuming this is elementary for everybody. So again, here's the b. When you divide a fraction by 2, you can multiply the denominator by 2, okay? And square. So let's add this number to both sides. So what happens? Well, this side is x plus b over 2 squared. In this case, is v plus b is negative, so minus 7 halves squared. What about the right side? You change the 2 to 32 over 16, so you can add this up, you get 81. So 81 over 60. If you take a root, the left side just comes out, and the right side is plus minus the square root of 81 over 16. As you know, this is, of course, 9 over 4. We are going to move this and make it positive 7 over 4 on the right side. So if you add them up, you get 16 over 4, 7 plus 9, 16 over 4, which is 4. If you subtract them, 7 minus 9 is minus 2 over 4, which is negative 1/2. So those are the answers, everybody. We want to solve by the quadratic formula. So in order to do that, first and foremost, you bring everything to the same side. That means you're going to move the 5. And A is 2, B is 4, C is negative 5. Plug it in. X is minus B plus minus the square root of B squared minus 4AC over 2A. Plug it in. $16. And then it's plus 40, makes it 56. 56 is the product of 4 and 14. So the 4 comes out as 2. It's important to do that because there's a common factor of 2. And I want to make sure you understand you can't drop the negative 4 and 4. Rather, this is 2 times negative 2 plus minus the square root of 14. You can drop this and change it to 2, and this goes away, and here's your final answer. What about this case? A is 7, B is 4, C is 3. Put that in. $16. 3 times 7 is 21. Times 4 is 84, so minus 84. 16 minus 84 giving us negative 68. Again, we notice this number, this is 68 is 4 times 70. Therefore, 4 comes out as 2, and this negative, we replace it with the I outside. I want to make sure everybody can see this I is outside. That's why in many texts, they put it in between so there is no ifs and buts about it. Again, we have a common factor of 2. So I'm going to take out the 2 minus 2 plus minus the square root of 17. This 2 goes away. This 14 changes to 7. And that's the final answer. Here's part C. We are going to multiply both sides by LCD, which is x squared, and we're going to say x obviously can't be 0 because this is fine. This one says x can't be 0. This one says the same thing. If it has a different value, you have to mention it. Now, if I multiply this, and by the way, this is one way to do that, okay? The product of these two is 2x squared. The product of these two is minus 4x. And the product of these two is negative 1. And the right side makes it 0. A is 2. B is 4. C is negative 1. Plug it into the quadratic formula. Minus b minus 4 plus minus a squared of b squared 4 squared minus 4 ac 4 times 2 times negative 1 over 2a or 2 times 2. And let's simplify. 16 plus 8 or 24. 24 is the product of 4 and 6. And again, in all cases, 2 came out, class. So again, you can't drop the negative 4 with 4 or anything like that. You have to factor out the 2. You get minus 2 plus minus the square root of 6. Now this goes away and changes to 2. This is completely gone. And the reason I'm showing both ways, class, because in case you see that you don't want to drop the 2, but this is one fraction giving you negative 1. This is the second fraction. My point being, this is the correct answer, so is this one. But if you write it as one fraction, you can't drop the denominator. Let's switch gears and look at absolute value equalities. How do we solve it? Number one, isolate the absolute value so that the equation is in the form of absolute value of ax plus b equals c. If c is negative, there's no solution. You're done. If, for example, this one. If c is positive, then we proceed. Since this is positive, we're going to proceed to what? Separate the absolute value into two equations. You drop the absolute value and you write ax plus b equals c, ax plus b is minus c. So drop the absolute value and make it 4x minus 7 is 5. 4x minus 7 is minus 5. So the following, I hope you see that this represents two equations. Now you solve both equations and you check. So to solve, I'm going to move the negative 7 becomes positive. Then I'm going to divide by 4. And here's what happens. If I add 7 and 5, I get 12 over 4, which is 3. If I say 7 minus 5, I get 2 over 4, which is 1/2. And it is extremely important to check. So I'm going to show you if we check the answer and I check one of them. For example, I'm going to check 1/2. So, and checking takes place with the original equation. So you would say 4 times x, which is 1/2, minus 7. And we're going to put a question mark because we are checking to see if it becomes equal to 5. So as you can see, this is 2 minus 7. And this is absolute value of 5. And yes, it is 5. It checks, and you can check the other one on your own. What is the difference between A and B? In part B, you have to move the 1 in order to go with the very first step, which is isolation. So here's the common mistake that students make. They just move on with this precision. Don't have to move the 1 first. Because this is positive, you're going to drop the absolute value and make up 2 equations. We're going to move the 5. Negative becomes positive on the right side. So 5 plus minus 2, we're going to divide by 2. And 5 plus 2, 5 plus 2 is 7 halves. 5 minus 2 is 3 halves. And again, you really should check. So I'm going to check one of them. Let's say we are going to check this one. So I'm going to write with always the original equation, 2 times 3 halves minus 5 plus 1. We want to see if it's equal to 3, and I'm going to put a question mark because we're checking. So the left side, we should finish the job and check to see if it gives us 3. So these two cancel each other. Okay, so we have 3 minus 5, which gives us negative 2. In an absolute value, when you drop it, becomes positive 2 plus 1 becomes 3, and it check marks. So again, I suggest you check the next one. Solve each inequality, graph the solution set, and write the solution set in interval notation. So this is an absolute value equality, and I'm going to remind you, if absolute value of x is less than a, and a has a positive value, then x becomes sandwiched between the two. So the very first step is to isolate the absolute value, meaning there should be nothing next to it, and there is nothing. So you sandwich this between positive and negative 7. We're going to subtract 3 from all 3 sides. We're going to divide all 3 sides by 2. And this is the solution. So we just solved. Now, interval notation is the following. This is interval notation. And why are we using parentheses? Because the endpoints are not included. If we had the equality, we would use bracket. And of course, here's a number line. We are going to go from number -5 to number 2, and -5 and 2 are not included. So we go like that. You have 2 choices. You can put parentheses, or you can put a hole here. So hole. Of course, underline your choice, okay? What's the difference between A and B? We have to isolate because the absolute value is not isolated. Move the thing that we subtract. What happens when it's negative? We say absolute value of something is less than or equal to a negative number. There is no solution. Okay, everyone? When we have absolute value of x less than a, and a is positive, we sandwich between the two. When it's negative, there is no solution, everybody. What happens when we have an absolute value inequality and it's greater than? If absolute value of x is larger than a and a is positive, then x is less than minus a, or x is larger than a. In other words, what we had in the previous page was an intersection of events. Now we have the union of events. In other words, again, in the previous page, what we had in common. Now that's a different story. So the very first thing is to move number 3 and the right side becomes 10. The next step is to divide both sides by 2. Now it's completely isolated. So the very first step is to make sure your equality or inequality makes no difference. It's completely isolated. Now, according to this, you drop the absolute value and it says less than negative of this number or larger than the positive of this number. And you, since you have the equality, you use the equality for both cases. Pay attention why we have the equality, because originally we have the equality as well. Now, of course, we solve each one as follows. This one we need to add 1. This one we need to add 1. And in all cases, you divide both sides by 3. One thing I want to remind you, when you divide by a number, if that number is negative, the sign will flip over. So x is less than or equal to negative 4/3, or x is larger than or equal to 2. That's the solution, and you're done with the solution. What I want to show you again is the interval notation. Less than or equal to -4. That means from negative infinity to -4/3, or means union, the 2 to infinity, and we use brackets. So pay attention to the interval notation. So this is the interval notation. On a number line, we locate -4/3, which is -1 and 1/3. This is -1, this is -2 in between, and about 1/3 of the way. So you can put a dot and to the left of it. Or x is larger than or equal to 2 and to the right of it. You can put either a solid point, we can do it this way, class. We can put a solid point to the left, solid point, not a hole, okay? Solid point to the right. Or we can use brackets. Don't mix them up. Whatever they ask you, you follow them. All right, we are going to move the 10. And we get -6 on the right. Now, this is important to understand. When we have a negative sign and this is larger than or larger than or equal. Think about this. It says an absolute value is larger than or equal to a negative number. It doesn't matter it's -6 or -1 or -10,000. This is always a true statement. This is always a true statement. So what's the answer? All real numbers. You can write R, all real numbers, or negative to positive infinity. This is the interval notation. If you were to graph this, you would simply shade the entire number. Solve and check. Generally speaking, when you deal with root functions, you want equations, you want to solve and check. And if you happen to have the even index, some of them may not work. So in order to solve, the very first step is isolation. This must move, number 7. So isolate this, move the 7. Then because it's a square root, raise both sides to the power of 2 to undo it. Obviously, this comes out. And of course, x squared minus 2 times x times 7 minus 14x plus 49. I'm assuming nobody has any problem with those identities. And so I'm going to move everything to the right, meaning this gives me minus 2x, meaning minus 16x, and this gives me 40. I want two numbers. The product is 48. And the sum is negative 16. Those are 4 and 12. However, because it's negative, both of them are negative. So the answer is either 4 or 12. So we have two answers. And we must check. Checking takes place with the original equation. So let's plug in 4. When we plug in 4, what happens here? It's 8 plus 1 is 9. 9 comes out as 3 with 7 becomes 10. Is 10 equals to 4? No. Therefore, this is not a solution. The terminology is it's not working. It's known as extraneous solution because it's not working. We just found it in the process. Let's plug in number 12 here, everybody. So what happens? 2 times 12 is 24 plus 1 is 25. So this is 25. Comes out as 5. Is 5 plus 7 12? The answer is yes. It works. We are done. So a root function, you have to check. And the very first step is isolation. X plus 2 quantity squared equals x minus 1 times x minus 6. And if we want to solve this, we have to simplify each side by raising the first side to the power of 2, gives you x squared plus 4. This one is x squared. This is minus x. I hope you see that this is plus 6. So I want to make sure that you see that this is minus x. This is minus 6x. The middle term, you should be able to do it in your head, minus 7x. As I said, minus 1 and minus 6, the product is 6. We are going to drop the x squared from both sides because they're identical. We don't have to move them. This becomes positive 7x on the left. This becomes negative 4. 11x is 2. X becomes 2 over 11. Four x plus 1 to the power of 5/3 equals 32, and that's a rational exponent. So we have to raise both sides to some power. So what power would that be? You look at this one. To undo this, you have to raise it to the power of its reciprocal, 3 over 5. So you are going to raise both sides to the power of 3 over 5. Okay, everybody? You raise both sides to the power of 3 over 5. So what happens on the left side? It basically becomes 4x plus 1. That's all. What about the right side? I'm going to remind you that the numerator is the exponent and the denominator is the index. So we write it as a root because we know the fifth root of 32 is 2. 2 cubed is 8. Subtract it and you get 7. 4x is 7. X must be 7/4. And of course, as always, any equality you can check. All right, we want to solve this at 2 times 3x minus 4 quantity squared plus 3x minus 4 minus 1. We could raise this to the power of 2, multiply by 2, and then combine like this. However, an easier way would be by substitution. Because we notice these two are identical, we're going to let 3x minus 4 be represented by a variable other than this variable. You can use anything you want. So let it be y. If this is y, this is 2y squared, this is plus y minus 1. And this we know how to factor. Because this is 2, again, you set it up as such. Y and then 2y, because 2 is a prime number, everybody. Now, all you need, and look at this one, you have to go with 1 and 1, one of them negative, since this one is positive. So if I put a positive 1 here, this gives me positive 2y, and negative 1 here gives me negative y, and I have the middle term. Okay, make sure the middle term is there. So y is either negative 1 or 1/2. Are we done? The answer is no, because we are supposed to solve for x. So let's set 3x minus 4 equals negative 1 and then 1/2. We are going to solve each equality, everybody. We are going to solve each one. So let's look at the top one. That gives us 3x equals 3, x equals 1. The bottom one, 3x equals 4.5 means 9 halves. And if I'm dividing by 3, I get 9 over 6, which is 3 halves. And those are the answers. In order to solve B, the best course of action is to let x to the power of 1/3 be m or y or z or any variable of your choice, as long as it's not the same variable that we have here, namely x. So make sure not to use x. So x to the power 1/3 is m. All right. Now, this is m squared equals 2m plus 3. Let's move everything to the left. And we get m squared minus 2m minus 3, which is a very simple case of a factoring. When two numbers, the product is -3, the sum is -2, so those are -3 and 1. M is either +3 or negative. Now, again, are we done? The answer is no. We are interested in finding x. And to find x, you raise this one to the third power and this one to the third power, and it gives you x equals m cubed. So x is 3 cubed, which is 27, minus 1 cubed, which is -1. And I'm going to leave it for you to check. You always check with the original equation and nothing in between. To solve this, we move the -15. You can solve it the way it is. If you have a difficult time seeing the methodology, you want two numbers, the answer is 50. The product is 15, the sum is -8. So -3 and -5. And for this one, you write r squared. If you don't see that, then you have to go by the substitution. For example, let r squared be x, then this becomes x squared minus 8x plus 15, and you do the math. So r squared is either 3 or 5, which means r is plus minus square root of 3 plus minus square root of 5. There are 4 answers, everybody. In part B, you really have two choices. You can see that this really means 1 over b squared, or this means 6 over b squared. So you have a choice. You can multiply both sides by b squared. We did that in one example involving x. I want to show you specifically the substitution method by letting b to the power of -1 be something. So we're going to use any variable except b, for example, x. If you do that, now this becomes 6x squared. This is minus 5x and plus 1. Now, again, the reason this is an easy factoring, this is 1. So you have to put 1 and 1. Both of them positive or negative. By the way, this is negative, so you have to go with negative. And then 6 is 2 and 3 or 1 and 6. So by trial and error, you can find this. And all you have to do, notice, the product of this one is 6x squared. The product of this one is positive 1. Now, this is -3x. This is -2x, so that works. So x is either 1/2 or 1/3. And I hope you see and you understand that this means 1 over b is x. Or b is 1 over x. In other words, they are reciprocal of each other. The reciprocal of this number is b, which makes it 2. The reciprocal of this number is also b, which makes it 3. Anybody wants to read this question for us? All right, a fitness club charges $20 as a monthly access fee and $2 per day. Express the monthly cost C in terms of daily usage. Part A. Well, we are going to define, I'm interested in part A for now. We are going to define our variables. So we let some variable, for example, X represent the number of days. So the cost, we have a fixed cost of $20. No matter what, in order to access, we have to pay this. And then a variable cost, this is the slope. Y equals mx plus b. In this case, c of x equals 2x plus 20. What would be the cost if we use this club for 15 days? Replace the x with 15 for part B. 30 and 20, they add up to $50. So I hope it's clear to everybody. All right, so here's the final question we are going to look at here. If the length of a rectangle is twice its width and its perimeter is 90 meters, find the dimensions of the room. Let's draw the setting. So this is a rectangular shape. If this is the width, this is the length. And the length is twice its width. So L equals 2W. And that's important to see. Now, L is 2 times W, and the perimeter, which has the formula of 2L plus 2W, is given as 90. All right. So let's replace the L with 2W. So this is 4W plus 2W makes it 6W. And we divide both sides by 6. And the width becomes 90 divided by 6, or 15 meters. Anytime you do a word problem, if units are given, you give it back with the proper units. And the length is 2 times the width, so 2 times 15, or 30 meters. And now notice, if you add these two numbers, 45 times 2 gives you the perimeter of 90 meters, so it works. You should always check your work.